Water molecules, molecules of H2O, sometimes dissociate to produce a hydroxyl ion, which is OH minus because it retains the electron, and a hydrogen ion H plus because it leaves its electron behind. This happens normally, and water molecules occasionally dissociate and then reassociate and become H2O once again. In pure water, the number of hydrogen ions, H plus, is equal to the number of hydroxyl ions, OH minus. And if one were to measure how many of each there are, it would be 0.00000001 moles per liter, which is 10 to the minus 7th moles per liter, which we write as pH 7, taking the negative log. But a solution's pH does not have to remain 7, because one can add substances to water which then produce a hydrogen ion, and thus they are acids, or they remove hydrogen ions, and thus they are bases. And so, therefore, in this example, the nitrogen dioxide from car exhaust can combine with water to produce nitric acid, and the sulfur dioxide produced from the burning of coal can combine with water to produce sulfuric acid. Both of these in solution will add hydrogen ions to the solution and thus be acidic. The pH scale is important because one must distinguish between a strong acid, that would be, say, battery acid or stomach acid, and a weak acid, like apple juice or lemon juice. And so therefore there is a pH scale. Weak acids are those acids whose pH are close to the neutral solution, so they are only slightly acidic, and the pH value is pH 5 or 6, close to the neutral pH of 7. In contrast, strong acids have a much higher concentration of hydrogen ions than a neutral solution, and their pHs would be farther from 7, say pH 1 or 2. In the same way, bases whose pH is greater than the neutral pH of 7 can be both weak and strong. A weak base would only have a few more hydroxyl ions than at neutral solutions and would have a pH of, say, 8 or 9, while strong bases would have far more hydroxyl ions than one finds in neutral solutions, and its pH would be closer to 13 or 14.